It's another semester of fun and cold winter, So first things first, I just want to say I'm very thankful that I'm able to be here today to talk about this with you. Bitcoin is definitely an interesting technology that I didn't realize the beauty in it, to be honest, until around a year ago is when I started to really pay attention to the actual technological innovation of it. Now, in terms of cryptocurrencies and everything, before I get into specifically that and my presentation, I'm just going to talk about me a little bit. So I am a Christian. That's my first and foremost thing of my identity. And I like to let people know that. And I mean, none of this presentation is about that at all. But I am a DSU alumni, so I got my bachelor's in cyber operations and my master's in computer science. I graduated actually May of 21, so recent grad. And since then, in June, I was hired as a research engineer here at Dakota State, and I also do adjunct professing. So last semester I taught computer science 1. This semester I'm teaching intro to PsyOps, so if any of you are in my class, I'll know tomorrow. And hopefully we have a good time. But yeah, so really am super thankful for my time here at DSU. I mean, it's enabled me to, 1, have the job that I do have, but 2, be able to learn other technologies other than just things we do here at the school, such as Bitcoin. So I actually became interested in the cryptocurrency space in 2017. Now, why? If you know anything about the markets of cryptocurrencies throughout the years, 2017 was actually a really big year in terms of price movement in markets. We call it the 2017 bull run, but Bitcoin and some other cryptocurrencies, I mean, Bitcoin had a price of just over $20,000 and then went into its bear market. So for me, as a person that I was interested in how I can make money on the side other than my job, I was interested in investing in markets, and cryptocurrency was one of those interesting new things, and it was a lot easier to work with in terms of like bank accounts and versus like stock market stuff. So if you have no idea about any investing stuff, it's totally okay. It's not really what this presentation is about. But in 2021, I would say I officially became a Bitcoiner. So what that essentially means is, for me, and I would say a lot of others in the space, I am what they call a Bitcoin maximalist, meaning that I believe that Bitcoin is the only blockchain technology that can solve the problem of money. So you may, if you are interested in cryptocurrencies, you may see, well, there's thousands of them now, but many other cryptocurrencies do not solve what Bitcoin solves. A lot of them, I mean, if you have seen the past year of NFTs, Dogecoin, Shiba Inu, things like that, a lot of them are really just for money, money purposes, money grabs, not specifically using it as money. So it's definitely an interesting take to look at Bitcoin and why Bitcoin was even created in the first place. And then we'll go into the Lightning Network. So my Slack is at Serial. My Discord is Zomix #1337, and then my Twitter is bbellseria20. And if you have any questions like throughout the night, I'm gonna try to answer those at the end. And if you do have a question, just raise your hand. Because there's a lot of content in this, honestly, that I'm trying to pack into like 1 hour, and that's almost impossible to really do because I could talk about this for like 2 weeks straight. So the topics we're going to cover today is, what is a blockchain, what is money, what is Bitcoin, and what is the moral case for Bitcoin. So we're going to cover 4 different things mainly, and then also the Lightning Network, which is intertwined with Bitcoin. So what is a blockchain, right? Anybody actually know what a blockchain is? A you don't, it's totally okay. Yeah, you got an idea?
I've done research, I suppose, but I'm not a genius at it.
Oh, no, it's fine. Yeah, I totally understand. It's blockchain is essentially just a type of database, honestly. I mean, when you think about a database, right, it just stores data, information. A blockchain is essentially doing the same exact thing, except it is more so an immutable ledger of blocks chained together. And I'll talk about kind of how that works, but it actually does incorporate some of the things that we learn here at the school. So like in data structures, or 250 in data structures, you're gonna learn like linked lists. It uses distributed networking, reaching like consensus. It uses hashing algorithms. Bitcoin specifically uses SHA-256 for its mining. Digital signatures, like elliptical curves, and then public and private keys, right? So these are the main ideas within blockchain architecture. It can seem very complex, and it most definitely is when you get down to the math of blockchains. But in the overall grand scheme of things, it's really not too complex. So it's a little small on the right, but essentially a construction of a block, if we look at, say, a block like Bitcoin, it has usually a block number, which is its height, the number that the current block is, the current block hash value, a previous block hash, a Merkle tree root hash, which I'm not going to fully explain that, a timestamp, the size of the block. In Bitcoin's case, it's specifically around 2 megabytes per block, and can reach 4 megabytes. And then a nonce value, and this value is just a random 32-bit integer that miners can change to try and solve the puzzle piece, which is the block hash. And then if you have a full node, which I'll get into what a node is, but you will list every single transaction inside of that block. Now, the Merkle tree root hash is actually a hash of all of those transactions into one hash. It's just taking all that data and compressing it pretty much. So, it's a little hard to see, but I can zoom in a bit. So, when we look at a block, this is pretty much a breakdown of a block and what it is, and a blockchain. So we can see that we have many, many transactions on the bottom. These all go up into the Merkle tree root hash. That is included in the block, and then the block is split between different things, right? So you can see that the way that blocks are actually chained together, it's taking essentially a previous block hash and putting it into the next block. So the reason it does that is because you can't go back and change the data beforehand, because if you do, if you change one bit, the whole entire hash of everything changes. So it screws up the whole blockchain and thus invalidates the data. So it's an interesting way to store information, and specifically within the most prevalent use case now is cryptocurrency. That is pretty much one of the best ways to kind of store information about money, because it keeps everything true to its word. So this was a question that I brought up on the Google form that I sent out, if anybody did fill it out. What is money, right? So this is an interesting concept that I honestly had never been taught in all of my years of school, and it's kind of unfortunate because I really wish that I was taught it. And I didn't really understand economics until I started learning, mainly after COVID happened. So I had a lot of free time, and I sat down and started learning economics and what actual money is. So I'm going to throw that question out. Anybody feel free to try and guess what money actually is. Does anybody know an example of money?
A dollar bill.
Dollar bill, yeah. Everybody uses the US dollar, right? There's plenty of other examples of currencies that have been used. So what is money? Money is essentially a concept of a good that is able to be used as a medium of exchange, a store of value, and a unit of account. Okay, so a medium of exchange, what do I mean by that? Well, exchanging goods with this medium, right? So just like we transmit data over, say, Ethernet, right? That is a medium that we use, a physical medium to transmit data. Money is the same exact thing, just for exchange of technically work or energy. And a store of value, right? If you store your money, say, in a bank account, you really do hope that that money stays that amount, right? And that it still stays as its own purchasing power that it originally had. And then you have the unit of account, right? So for US dollars, we have the unit of account broken down into, well, pennies pretty much is the lowest that it can go. And we can use different coins or different bills to account for what the value we are trying to transact, okay? So those are the three main things about money. But there's also a fourth thing, which is a term I didn't really know until roughly like 6 months ago. But it's called salability. So salability is defined right here as the ease with which a good can be sold on the market whenever its holder desires, and also have the least loss of its price, right? So for an example, Jake, if I were to give you $100, what do you expect to get? $100. $100, right? So there would be a problem in that case if I gave you $100 and then you were to have it and it would not be $100, correct?
Yeah.
Yeah. So that is pretty much the term of salability. Now, this is the most interesting thing to understand, is that anything can be money. Nothing constitutes what should and should not be money. It technically is a free market based on what the user's choices are. And we've seen this throughout history, actually. I'm not going to give you a whole history lesson of like going way back into the Roman Empire and everything, but we have used gold, silver, copper, seashells, rice stones, glass beads, etc. And these are very, I would say gold's the least primitive of them before paper money came around. But like, for an example, some countries in Africa used to use seashells and glass beads. Now, anybody know why that's a really bad idea? Goes into the concept of, yeah?
You lose the value stored because you can just use it for
Right, exactly. So you bring in this concept of what we call today inflation. Its supply can be manipulated very easily, right? Now, of course, way back then, they didn't really understand that, and so to them, it was scarce, right? That is another thing about money, is that it needs to be scarce. That's why gold for a long time was used as money, because the supply of gold stays at a constant rate of about 5% every year with its ratio of stock coming in. So this is where we get into the concept of money hardness. So easy versus hard money. Easy money is money that can be manipulated very easily with the amount of supply that you can inflate the economy with, right? So, for an example, seashells and glass beads. The Europeans actually abused this when they first entered Africa to take over some of the countries. Some of the European countries figured out that these African countries were using primitive money. And for the Europeans at that time, I want to say they were using silver or gold. And so for them to buy, I don't know, billions of glass beads or seashells, right, that was very easy. And they would introduce this into the economy because these merchants didn't understand the concept of, if they were to take this in, that they would be inflating the rest of the economy after it's distributed throughout. So gold itself has a what we call a high stock to flow ratio. Like I said, it's very hard to introduce gold into an economy, mainly because it's super hard to mine and it's very scarce. We know this, well, one, because, you can look back, especially in the California gold mining days, 1850s gold rush. Investing into mining companies was a very bad idea because they didn't really make a lot of profit because it was very rare to find gold. So glass beads, I mean, it has a very low stock to flow ratio because it's easily manipulatable, right? So I bring this graph up because I personally did not know this about the US dollar, which is very interesting to look at the US dollar. And here's another thing. If you didn't know, the US dollar is the global world reserve currency currently. Okay? It has been that since 1971, after Nixon unpegged gold from the US dollar. Now, this graph is showing that the Federal Reserve was actually made in 1913, and we can see that the purchasing power of the dollar has fallen a lot since then, right? So essentially a dollar, well, in this graph, 2020 was worth $26.14 in 1913, right? So why? Well, we have inflation, right? So you can see there's a few dips throughout the years, and you could probably match up what kind of things happened in those years, right? So past the 1930 mark in the middle, that 1991 to 1471, well, anybody guess what years those were? World War II, right? And then eventually we got into the 60s to the 70s when we had Vietnam and other wars just going on. But throughout time, after especially 1970, once we unpegged from gold, it's very interesting to see how much has changed economically according to statistics. So I'm going to bring up a website, which is kind of interesting. This is a lot of data and graphs from the Department of Labor and other just statistical websites. But it's called WTF Happened in 1971. Okay, so like I said, Nixon actually detached the U.S. dollar from gold, and since then we have fully been on what we call fiat currency. Now, if you didn't know that, the U.S. dollar itself is not pegged to anything like scarce, technically. It used to be pegged to gold directly, and its price would fluctuate based on like what gold was doing, but nowadays it doesn't. And so since then, you can see some economic data that is pretty interesting. For an example, like growth and productivity compared to hourly compensation, right? So like, what is your hourly pay versus the productivity that we have produced since 1972? We see a split. The compensation has actually gone down for the amount of productivity that has gone up. We see the GDP per capita of countries, that's GDP per person, versus the real median weekly earnings. Usually throughout these graphs, you're going to see that our weekly wages have kind of just stayed almost stable over time. I mean, income gains, early post-war, income growth of top 1% versus the 90%. And it's just very interesting because today we do actually kind of see that, right? I hate to say this, but in a way it is a little bit true because of how the stock market works and just how we have investments. The rich do get richer and the poor possibly get poorer. It depends on certain factors, of course. But it's just interesting to see the economic data that has come out since 1970 and then kind of put that into perspective, because especially when you're thinking about purchasing power, it's like my dollar way back when was worth a lot more than it is now. That's not necessarily a good thing. This one's actually very interesting, so I think it's a good thing. Median male income has kind of flattened. Female income has actually gone up, according to the Bureau of Economic Analysis. And I found this one interesting too, which it actually makes a lot of sense. So, I mean, personally for me, I'm 23 right now, and I'm kind of in that age range of looking for a house. Houses are expensive, I will tell you that. And to be, at least for me, like, I don't have a family, I don't have a wife or anything, but we do definitely see a lot of families where both spouses are working a lot more versus just the husband only working back then. And this has just gone down basically since the early 1900s. And we do see a rise in the wife only working as well. So it's a little bit interesting. And then this is probably one of the fun ones, is just looking at prices back in 1971. A new house, like average $25,000, a car, $35,000, $60,000. And of course, some of these numbers can be definitely skewed because it depends on what house or car you're getting. But just the average that it comes out to be is very interesting. Some people like to actually kind of base inflation on what milk price is. So $1.17 a gallon back then. I honestly don't know what it is now. But back to this graph, we can see that versus gold, fiat currencies have actually gone down a lot in the 1900s to leading to 2020. We can see the US dollar is still the strongest currency in the world. Makes sense because it's the reserve currency. The British pound is next, and then I would say, well, it has the Japanese yen, but there might be currencies that are stronger than the yen. So, now, how do we attach blockchain and money, right? It's where Bitcoin comes in. What is Bitcoin, right? This is probably one of the hardest things to express to you because, I mean, I could go on for hours about this. So let's just talk about the history first. So Halloween of 2008, Satoshi Nakamoto, an anonymous person, nobody knows who it is. We assume it's a he, a man, that was Japanese. We don't really know, but that's how he addressed himself. And he released the white paper of Bitcoin, Halloween 2008. Now, this white paper was titled Bitcoin, an Electronic Peer-to-Peer Cash System. And during this time, he actually, this was released on a cypherpunk email list. And for me to think about this in 2008, I mean, I just turned 10 years old. So it's kind of interesting thinking of the time frame of this and me going back and learning it. But Satoshi was made fun of a lot within the cypherpunk email list because many people had been trying to solve this digital cash problem for a while. So that is one thing I want to make clear, is that Bitcoin is not just like, it wasn't just made in a day or something. Like it took a lot of research from other computer scientists in the past, and I'll actually apply that with some of the things in Bitcoin in a minute. But it wasn't until Hal Finney, a well-respected computer scientist that worked on PGP, he worked with Satoshi, and he read the white paper and he thought it was a brilliant idea. And they started to work bugs out. And it's really funny because I didn't realize this until a few months ago either, but Bitcoin version 0.1 originally was released January 9th, 2009, and it was just running on Windows NT 2000 and XP in 2009. So it's kind of an interesting thing to think about. It wasn't running on Vista, and Windows 7 was just about to be released, I'm pretty sure. And Bitcoin was running a little bit before that, January 3rd, 2009, where Satoshi mined what we call the Genesis block. So any blockchain starting at block 0 is called the Genesis block. And we know that, we can prove that by going and looking at the Bitcoin blockchain. And I have an image of it over there with the timestamp 1215 p.m., January 1st, 2009. And yeah, so it's written in C++. All the code is openly available on GitHub to view. That's probably one of the best aspects of it. It's free and open source software, right? And two of the big things, Satoshi solved the double spending problem, a complex problem within digital cash that essentially is, okay, imagine I'm giving Michael and Jake the same exact money in the same transaction, and for me, that would be fine, right? But for them, that's not fine because I get to spend my money twice, whereas one of them actually would be invalidated eventually. And that pretty much was the problem with double spending that was solved with the consensus mechanism used in Bitcoin. Now the Byzantine generals problem, that had been solved before, but Satoshi applied it in a different way through the proof of work mechanism that Bitcoin uses, which I'll explain in a minute. So what is Bitcoin essentially at the core? Let's talk about its fundamentals real quick. It's a peer-to-peer model, so there's no trusted third party involved. It's completely just like me to Jake, me to Michael, or whatever. And that honestly is a very powerful thing because it gives users a lot of freedom individually, not having to trust a third party, especially with finances, right? So for me right now, I mean, I think about it. How many different credit cards, debit cards, things have I used? I'm trusting like Chase Bank with my credit card, trusting my bank account or my bank here in Madison, or Betterment, my online bank, with my finances. And not to say that I don't necessarily like trust them, right? I mean, for them to take my money or do things with it would be illegal. But no matter what, they have control in some degree. So that's where Bitcoin comes in, and I have full control. It's permissionless, so what I mean by that is that it does not cost you any money to be a part of it. You don't have to buy it to be a part of it. And anybody, it's not like segregated in any way. Like anybody is allowed to be on the network and use it. And that's one of the most powerful things about it is because no matter what, every user has a vote in the system if you're running a node. And if you're not running a node, you're running on someone's node if you have a wallet. And you can trust the trustlessness of Bitcoin based on its rules. So that's a weird term to think about, but it has a trustless consensus because there, no matter what, is 100% verification always by the nodes on the network. So I don't have to trust the peer that I'm sending money to. I know that they are playing by the rules because if they are not, the network is going to invalidate them. Okay. And so that essentially is like just thinking you're abiding by the law. And since everything is in code, it's not like there's a human there to decide whether it's right or wrong. Like the code is deciding if it's right or wrong, and it never changes. So then we talk about proof of work. So I'm going to get into kind of how proof of work actually works in a minute. But proof of work is the security mechanism in place for Bitcoin to establish nodes, or not nodes, blocks, onto the Bitcoin blockchain. And it does this by constantly just cranking out hashes. Like the best way to describe it is if I were to go into CyberChef and tag SHA-256 in there and just start typing away until I hit a specific hash with amount of leading zeros, would I actually get a block hash? That's correct. And that's all these miners do. Like that's literally, they're just cranking out hashes all day. This is one thing that I like to clear up a lot of times because it can be confusing. A miner is not a node. They're two separate things in Bitcoin. Now, I'm not going to get into other blockchains and how they work on proof of stake. I only believe in proof of work, I will say that. But essentially, when you switch over to proof of stake, a miner becomes a node, which can be detrimental to the network, in my opinion. But essentially, a user of the network becoming a node, you are running the code of Bitcoin Core. And you have a vote in every single fork of the system. And a fork, all it is a software change, right? And this has to go through an immense process to change Bitcoin's code, verified by thousands of people. And that's one of the most powerful things about it, is that it actually is a true user-controlled money, because you can vote for it, vote against it, and that, to me, that's a very powerful thing with individual freedom and rights. Excuse me. So blocks are mined roughly every 10 minutes, and there's a reason. So I have had this question before. Why can Bitcoin not just inflate its supply? Well, one, on the screen there, I have 21 million is the max Bitcoin supply. That's the amount that will ever exist, and that's not going to change. Why? Because the users are going to deny anybody that tries to change it. And that makes it deflationary, and I'll get into that a little later. But the difficulty of the network adjusts about every 2 weeks. And what I mean by that is, as you add more miners to the network, there's going to be more hashing power, right? So currently, right now, we are at 183 exahashes a second. So if you think about that, you have tera, then you have peta, then you have exahash, okay? So like, that's a lot of hashing power. 183 million terabytes would be 183 exabytes. So the network is very robust, and that contributes to the security of the network. And so that difficulty, if you're adding more hashing power every 2 weeks, the difficulty will adjust and make it harder for the miners to actually mine blocks. That's why roughly blocks are mined every 10 minutes, because it takes a certain amount of hashing power roughly to get to the next block. So the unit of account for Bitcoin is a Satoshi, which is 1/1,000,000th of a Bitcoin. So 100 million Satoshis equals 1 Bitcoin, okay? And that makes it very powerful because it's divisible, right? So 1 Bitcoin right now, I don't know, I didn't check the price before I did this, but I want to say it's roughly 40,000, 41,000. So that means 1 Satoshi, roughly in US dollars, is like 0.00004 something, 410. So very small amount of money, okay? But eventually in time, being a deflationary asset, you can expect the price of a Satoshi to rise, especially against the US dollar. But block rewards also half every 210,000 blocks. So the starting block reward in 2009 was 50 Bitcoin per block, okay? So for every miner that found the exact block hash that was needed to validate a block, would get 50 Bitcoin. And Satoshi has around 1 million Bitcoin, I want to say. It's somewhere around there. But we assume he doesn't own the keys, and he left the space in 2011. So nobody really knows like if those wallets will ever be used again, and nobody's really worried about it either. But this times to every 4 years of when it halves. So in 2013, it halved to 25 Bitcoin per block. Then 2017, it was 12.5. And then 2020 was the next halving, specifically April. And now the Bitcoin block reward is 6.25 Bitcoin. Okay. So eventually it's going to get down to where, per block of Bitcoin, the last amount of Bitcoin will be mined in 2,140 a year. Because it keeps splitting in half. And if you work out the math, that's when it should roughly end. So 21 million will ever exist. That's the main thing. So this is a picture of my Bitcoin node that I run. Just on a Raspberry Pi. It's nothing crazy, right? And it honestly gives me a use case for my Raspberry Pi because I didn't have one before. But you can see I have a 4 terabyte drive there with it. I mean, honestly, that's the power of all you need to run Bitcoin, to be honest. Like, just, that's a Raspberry Pi 4 specifically. But the Bitcoin blockchain is only around 550 gigabytes of data. That's not a lot, to be honest, nowadays, and that's over the past 13 years. So you can expect it's not going to grow much more over the next 13 years, assuming the block size does not change, and I can say it's not going to change. But since every block is 2 megabytes, you can roughly think all the way to, I don't know, you can predict how big the blockchain will be in any year based on how many gigabytes it is per year. So that's my node, and that's not what I meant to do. I want to show you, this is actually the software that's running on it. So I have an operating system called Umbrel running on it, and it's running over the Tor network. Yeah, I know, spooky, scary stuff, right? And it's, of course, like accessible over the Tor network, but for me, you can see that, I mean, I'm not afraid to show you how much Bitcoin I have in this node. It's not like my true Bitcoin stash, but you can see in my Lightning wallet, I have 1,024,000 Satoshis, and in my Bitcoin wallet, I have 49,000 Satoshis. And you can see that it's synchronized to the blockchain right now, block 718,083. I have connections to other peers on the network. The hash rate is 168 exahashes a second. And yeah, 437 gigabytes is roughly the size of the blockchain. And I'll get into the Lightning Network in a bit, but honestly, this was super easy. Like, I flashed this on an SD card, started it up, and it downloaded the blockchain. Really easy, right? And not really that expensive, to be honest. Like a Pi, you can get roughly cheap. I don't know. I mean, I know they've gotten a little more expensive due to supply shortages and everything, but and then the 4 terabyte drive, that was like $100 or something. But I also host other things on there, so that's why I bought it. Now a mining rig, that's a different story. This is just one mining rig that produces about 100 terahashes a second, right? So I said 183 million was 183 exahashes, right? So 100 terahashes for one miner, it's really not a lot. But yeah, they're pretty expensive. And personally, I do not run one. I do plan to run one eventually. Just haven't gotten to it yet. It'll be easier once I actually own a house. But yeah, you can see the output wattage is 3,000 watts, so these bad boys cook. And it's pretty funny too, because I've seen interesting ways of people actually converting that energy that it outputs in heat into like producing their water heating for their houses, or using it in some other form for even all the way down to dehydrating fruits. And just, yeah, it's pretty interesting. But yeah, these things are not cheap, and they are beasts, because originally Bitcoin was actually mined on a CPU, and eventually went to GPUs, and then we got ASICs, which is application-specific integrated circuits. So these chips that are inside of these miners are specifically designed to mine Bitcoin. That's all they can do. Yeah. So what is the life cycle of like a transaction? So we can see that, let's just start with Rob. Okay, Rob opens his Bitcoin wallet. He then, is sending a payment to someone else, and he scans Laura's address. Okay. Now, usually, I will say this, back in the old days, it was a lot harder to transact Bitcoin. Nowadays, it's gotten a lot easier. UI interfaces are way better. I remember I used to actually type people's addresses out, and these are like long strings, and if you get one thing wrong, you're screwed. So nowadays, it's easy because you got QR codes. You can just copy paste it. I mean, it's really easy. But yeah, so you fill out the amount and the fee, and then it sends. Okay, that's all that's done on the user side. Now, on the machine side, a wallet signs the transaction using Rob's private key. Okay, and then the transaction then goes to, say, my node on the network, and I validate that this transaction is valid. Right? Is Rob spending too much Bitcoin of what he has? If he is, well, it's invalid. And if he isn't, it's a valid transaction. Okay. Then, once that is passed by the nodes, every single node on the network verifies that. And then it's passed on to what we call the memory pool. The memory pool is just a pool of transactions that a transaction will be pulled out by a miner and put into a block. Now, transactions shift back and forth, like in and out of blocks all the time. And that's actually another aspect of why mining is so hard, because if the data inside of the block is constantly changing, like it's not like you can just have a single set of data and like fully just brute force that data specifically. The data is changing all the time. So it truly is like random, and you just hope that you get the block hash so that you can get the block reward. So the miner that solves the proof of work will propagate the new block onto the network. This block is then added to the chain, and before it's actually verified, the nodes have to actually look at it and be like, okay, is everything matching? Is everything good? And all this happens like literally within milliseconds, and it's crazy. It's nuts to think about that. But then on the other side, now Laura, the person that the Bitcoin was sent to, sees the first confirmation, and as the blocks are added on, more confirmations are added on. So yeah, that's pretty much the life cycle of a transaction. It's actually not really that difficult to understand. So how do we apply this? Well, Bitcoin over 13 years has proven its security and resiliency. And we know this because, well, one, it's never been hacked. And it's honestly theoretically impossible to hack. I know there's threats of quantum computing and stuff like that, but that's not really a concern, to be honest. And I will say this, exchanges have been hacked, like Mt. Gox in 2014. And, you know, people have lost tons of money using cryptocurrencies, but I mean, it's almost the same exact thing if you were to wire transfer to the wrong bank account, or if your bank account was hacked, or something like that. And then the block size war from 2013 to 2018. Not going to go into the specifics of that. It would take me a really long time. But we know the security cannot be overtaken by venture capitalists, governments, or miners even. So it's very interesting because, I mean, there are attack vectors to Bitcoin, but honestly, it's a true user-controlled currency. So what the rules are is what the users decide, and that's not going to change unless the users do decide to do it. So it's also proven itself to be a great store of value. I shouldn't have to explain that if you look at a Bitcoin chart in the market, that it's realistically only gone up and to the right over the years. And technically, if you look at how the value of it should go, it's almost logarithmic. So logarithmic would be an upside down exponential function, pretty much. And as the reason that happens is because the supply coming in actually flattens out close to zero. So we know it's a great medium of exchange, and we know it has a great unit of account. So, I mean, personally, you might not think this, but Bitcoin actually is pretty widely used. Maybe not in the United States, but in other places it is. Not as legal tender, but between people and commerce sometimes. And technically, if you want to use it in the United States, I mean, I can use Visa to spend my Bitcoin, but then I'm going to have to work with the tax implications because the United States law is very annoying. So, yeah, there's definitely plenty of things I could go into, but I'm going to get past that. So, we are very early in adoption, okay? And what I mean by that is actually seeing countries adopt it as legal tender, and it truly being widely used without me having to convert it to fiat currency, right? So today, because of the way the system works, I have to buy Bitcoin on an exchange. I don't get paid in Bitcoin. So one, I rack up fees from buying it, but two, that's just fees to the exchanges. The fees on Bitcoin are not expensive at all. But honestly, it's just kind of a very early time. You might not think that because Bitcoin itself is like $40,000. Like, dang, to buy one Bitcoin, that's kind of hard. But you don't have to buy one Bitcoin. You can buy 1/1,000,000th or 1/100,000,000th. Sorry. And El Salvador is the only country to have adopted it as legal tender. Now, I do think this is a good thing. I'm not going to go into the politics of El Salvador, but it's really interesting because they took a huge risk. Because Bitcoin, if you do look at it from market perspective against the US dollar, it's very volatile. I mean, just the beginning of December, it was at 69,000, and now it's at 40,000. So it's lost, $500 billion roughly in market cap. So, I mean, it's definitely interesting when you look at it in a market perspective, but that's really not the point of Bitcoin. Nobody cares. If you're a true Bitcoiner, you don't really care about the price. You just care to not spend it, to be honest. And it also promotes individual freedom and self-sovereignty. Like I said, you have a vote in the system as a user, and nobody is controlling that against you. Now, this is probably the biggest thing that's amazing about Bitcoin is that it honestly is the only money ever created that is unconfiscatable. Nobody can take it from you, which is a very powerful thing. No government, no person, no entity, no technology. Nobody can ever take it from you. Now, you might not really understand how that's possible, but essentially a private key is split up usually into 24 words. These 24 words are very important. You never should show them to anybody. It's called a recovery seed. And for me, I've memorized my 24 words of my hardware wallet. And I also have them in a steel plate encrypted, which I actually have with me today. So this is my steel plate. And I mean, I don't care if you see it, honestly, like the words inside of it, it's encrypted with layered encryption. And then this is my hardware wallet. So this is pretty much my bank account. Now, realistically, that's just a device to technically access my Bitcoin. My Bitcoin doesn't technically live on that. It lives on the blockchain. So I can be anywhere in the world, travel across oceans, countries, or whatever. And as long as I know my 24 words, no matter what, I can access it again. And that is honestly the beauty of that, because nobody can steal your intellectual property, at least right now. I don't know what's in the future, but now there's two problems with Bitcoin at layer one, and that is scalability and anonymity, right? So originally when Satoshi had this vision for a peer-to-peer cash electronic payment system, the problem is that Bitcoin's security and consensus is so good that it actually fails at scalability, which is not a bad thing. But realistically, Bitcoin cannot transact that much in terms of transactions per second. So that is where the Lightning Network comes in. The Lightning Network is a layer 2 solution on top of Bitcoin, okay, that is the payment solution, honestly, to use Bitcoin as payment. Not everything has to be a blockchain. I will say that downright flat. Like, it annoys me so much in crypto how they take any single thing and they're like, blockchain. And I'm like, you don't need it to be a blockchain if it solves this specific problem. Because essentially, like I was saying earlier, honestly, a lot of blockchains that are created within the cryptocurrency space is for these people to make money. That's not what Bitcoin is. So Bitcoin can only process around 7 transactions per second. It's really low. Lightning has the potential for 1 million transactions per second. And payment processing companies like Visa can handle, they claim, up to 25,000 per second. But realistically, it's around 5,000 per second. So now, how is that number attainable? Well, it really pertains to adoption. Many people, like myself, have to be running these nodes and on the Lightning Network, creating channels between peers on the network so that we are able to just send this money like constantly and super fast. I mean, literally Lightning, there's a reason it's called Lightning. It's because on Bitcoin, layer 1, like I said, each block takes around 10 minutes, right? Now, compared to the HTH system, like bank accounts and stuff, if I wire transfer to somebody, 3 to 5 business days. Yeah, I hate that so much. I'd rather take 10 minutes, but yeah, Lightning, it takes less than a second. And it honestly is just insanely amazing. The technology behind it is just incredible. And you can send all the way down to 1 Satoshi, which blows my mind, honestly, because, I mean, I can't even transact that in US dollars. Like, I can't transact 0.000046 of a dollar to somebody, but I can on Lightning. And then within its channels and how it works, which I'll get into that a little bit, you can even break it down into milli-Satoshis, which is really interesting with the payment process hopping through channels. So the fee that you take on for Bitcoin, right now, I just looked at it earlier, it was about 45, well, actually we can look. Let's see. So if you actually want to see how the blockchain is just running, we can look here. There's currently only 1 block about to be validated. That's the green block that you see. And the highest priority is 2 sats per virtual byte, and that's 12 cents. So if anybody wants to send any amount of money, any amount of Bitcoin, they can for 12 cents, right? I will tell you that you cannot do that in the ACH system today. Like, if I want to send $1 billion to somebody, you best believe the government's going to take some of that money. That's just a fact. And on Bitcoin, it would cost 12 cents. So, at least right now. Now, I've seen this fee go up and down all the time. I mean, earlier today it was 40 cents or whatever. But the cool thing is that you can prioritize it. You can pay as much as you want to have it as fast as possible, or in the next valid block. So let's go back here. So yeah, on the Lightning Network, the max fee, it depends on the channels that you go through, but you're pretty much only going to be accumulating up to around 10 Satoshis, which is less than a cent. So really not that much. So what are some Lightning applications? Well, we have payment apps. So there's an app called Strike, which I personally do use, and Blue Wallet I use. Strike is really, really neat. I honestly have no idea how they do it, how it works, but essentially, think of Venmo, right? How I can send anybody money on Venmo or whatever. But the problem is with Venmo, I mean, I have to trust them as a third party, and technically with Strike you do too, but the difference is that Strike is backed on the Lightning Network, which is backed on Bitcoin. So you can trust their security a lot more. So, for an example, with Strike, the money that I put into Strike is actually in a bank account. And whenever I pay somebody, it uses the Lightning Network. So like, it's not in Bitcoin originally, but they put it into Bitcoin and then it pays somebody, and you can pay any Lightning address that there is, just with normal fiat money, which blows my mind because for me, like before I was using Strike, I was specifically putting Bitcoin in the Lightning Network on my channels that I have, and I had to pay that way. But they've essentially connected the two worlds into one without the user having to truly interact with Bitcoin. So it blows my mind. But social media as well. So I don't use Squeaknode, but I do use Sphinx. It's really cool. I'm able to have chats with people, all decentralized, peer-to-peer, encrypted, over Bitcoin on the Lightning Network. And it's really cool how it works. So essentially to send a message, you have to pay 1 sat, but you also receive a sat when they send you a message back. So like you're never losing money unless they just never respond. So sorry if you get rejected, but it's pretty cool, honestly. And it's very new, so there can be things worked out with it UI-wise. And another part of it that actually Sphinx does incorporate is podcasting 2.0. So in terms of content creation, Lightning is super powerful because if you are able to connect, say, content that you want to put out there, right? You can pay someone like sats per minute or sats per hour or something for watching their content pretty much, right? So think of a world where, say we have a platform that is open source, so not YouTube, but say we have an open source video platform that works in a way like YouTube, but for every minute that I'm watching someone's content, I am directly paying them, which is such an interesting concept because for content creators, that's a powerful thing. Today, I mean, I can tell you that YouTube takes a lot of profit from a lot of people, and so do many other things. Twitch, you best believe they take a pay cut of what you make, and it just brings everything into a realization of like, we really don't need these centralized platforms to be managing this stuff. If we put it into a decentralized space, I can transact what I want to give someone directly, peer-to-peer. And to me, that's a very powerful thing. It can be used in gaming. Not going to get into NFTs. I like the idea of them, but the way they are being used right now, I disagree with. And it's really not the best investment in my opinion. But yeah. Then as well as burner phones. So actually today I bought a eSIM. I was telling my roommates that. And I put that on my phone, and I have technically a burner United States number that I paid $60 for a year, which, as many platforms nowadays that likes to take your information and use that against you, I'm like, yeah, I'll take privacy into my own hands. So that's pretty nice. Yeah, so this is the last thing, the moral case for Bitcoin. So in my opinion, I think fiat money has done a lot of disservice to the world. I can't go into every specific because I don't want it to get into a political thing, but honestly, it really does hurt me in my heart to know that there are people elsewhere in the world, outside of the United States, that really do not have the freedoms that we have. And Bitcoin is something that can solve a lot of this. Mainly because, well, it's anti-authoritarian. Nobody can control it. It takes consensus to control it. You have true property right that can travel across space and time, right? Space meaning I can go anywhere in the world, like I said earlier, and I have my Bitcoin always in my head. And then time, as time goes on, being a deflationary asset, the longer you hold on to your Bitcoin, the more value it should be in the future in a deflationary world. So it changes your time preference, what I have on here, shifting into what should I really be spending my money on, which I think is a really good thing, honestly, for a lot of people. Because, I mean, if I look back, in my 23 years, or I guess technically, like, say, 13, whatever, that I've been spending money, there's been a lot of things that I've bought that I really do not need. And for me to have a deflationary asset, holding on to it longer, like I said, actually gives me more purchasing power in the future versus an inflationary asset where, if you didn't know this, the CPI index of the United States, it's about to come out January 12th, but they release it every month. And in December, it was 6.8% inflation, meaning that in 2021, if you held, say, $100,000 in a savings account, which only gives you like 0.05% interest, right? So you're gaining literally like nothing. You would have lost $6,800 in purchasing power, which to me, that's theft. I mean, that's really not a cool thing, right? If I put $100,000 in the bank, I want it to be $100,000 throughout time, and the reason I say it's theft is because I worked for that money, right? And you're stealing my work, essentially. So that is another aspect, being deflationary, that I think is very moral. Now, like I said, it's also unconfiscatable, so you have that true property right. And everyone in the world is permissionless, like I said, can partake and understand how it works. The code is there on GitHub. Go look at it. Like, I understand that most of you might not understand C++. I mean, I barely really understand it, to be honest. But, I mean, there's definitely complicated code, but you can actually go and look at, like, some of the fundamental global variables that it has, like the supply cap. There's 21 million of it. That's not going to change. And that is an awesome thing because, like I said, every user has a vote. And I believe it's actually true sound money. The fiat, the US dollar, or just fiat in general, I do not believe is very moral. Mainly because, I mean, you can think about investing. I mean, personally, I've invested a lot of money before, and now 90% of my wealth is in Bitcoin. I took out, personally for me, nobody has to do this, but I took out all of my retirement and put it into Bitcoin. And there's a reason for that, because I have to think about this, is that for people around the world, outside of the United States, don't have access to a retirement account. They don't have access to the stock market. Some of them at least don't, especially under authoritarian regimes. You can look at, and I knew about this because Bitcoin's hash power fell 12% last week. But in Kazakhstan, last week, overnight, pretty much, the prices of everything pretty much doubled. And nobody truly knows exactly why an insurrection began, a coup against the government. But I mean, it hurts me to know that Kazakhstan's government resigned. 1, didn't care about their citizens. 2, shut off the whole entire internet in the country. And 3, fled to Moscow to get help from Vladimir Putin to send Russian troops into Kazakhstan and have a shoot-to-kill order. Right? To me, that's not right. And that's where, I mean, in a moral money world, not saying that money can solve everything, but the world runs on money. And having a more moral money definitely takes away that incentivization to attack other people. And it's weird to understand that, but if something's unconfiscatable, what gives me the incentive to like want to go and take somebody else's money if it's unconfiscatable? So there's really no point. A good person to actually listen to or watch videos about podcasts or anything, Alex Gladstein. He is the CSO of the Human Rights Foundation. Huge advocate for human rights, which I totally agree with him. And he is a huge advocate for Bitcoin because of that. So that's where I make my moral case for it. And there's plenty of other things I could go into. But if you want to actually kind of learn a little bit more about the economics and Bitcoin itself, these are 3 books that I recommend. The Price of Tomorrow by Jeff Booth, The Bitcoin Standard by Safety Namus, and Layered Money by Nick Bhatia. These books honestly changed my worldview. I 100% will say that. And then these are some of the podcasts that I listen to. I listen to plenty, but just plugging them as well. Preston Pish, Bitcoin Fundamentals, the Investors Podcast, Sapadina Moves, the Bitcoin Standard Podcast, and Bitcoin in the Bible. If you're not a Christian, the Bitcoin in the Bible, some of it might not make sense, but it's also really informational podcast. So with that, I tried to fit as much as I could with that time, but any questions? Yeah.
So the more Bitcoins that does it make it exponentially more difficult because you have to factor in all the calculations that were already made before you?
For blocks mining? No. The difficulty is just based on the hashing power on the network currently. So for an example, let's just say that we're at 183 exahashes right now. This kind of happened this past summer, 2021. China banned Bitcoin mining finally. They truly did. And Bitcoin's hash power fell 40%. Now, that clogged up the network. There were plenty of blocks that took hours to confirm, or even days. I remember I was using Bitcoin during that time. It took one of my transactions, because I didn't have high priority on it. Took one of my transactions 4 days to transact. Now, like I said, the network adjusts every 2 weeks. So 2 weeks later, the network was completely fine. And the mining was back to normal. Either way, if the network gets more powerful, it'll adjust that difficulty to make it harder. And if it falls, then it makes the difficulty easier. So that blocks are roughly mined every 10 minutes. So, hope that answers your question. Yeah, Kim.
First, I agree that the Bitcoin will be adopted soon in the near future, in 10, 20 years.
Mm-hmm.
But I find it a better idea to put the money that you want to put in Bitcoin into other somewhat bigger altcoin, that have a use case that will have a better growth rate, that you will have a better return than putting all of it in Bitcoin.
Yeah. So this is a hard thing to discuss because I understand what you're talking about, just investments in general, ways to make money. Right, yeah. So right now it's a really hard thing because we are so early in the space, right? The technology is 13 years old. I do think eventually, like I was talking about with say NFTs, eventually I think something like that will become a solution on top of Bitcoin, a layer 2 solution, because we have smart contract, the Lightning Network, it uses smart contracts to transact everything. And investing with Bitcoin into companies, that's going to take a long time, I think. I don't think that we can really see that type of future until honest, true adoption happens as the global reserve currency, which is something I do believe that it will be one day. Now, if we see digital currencies before that, possibly, I actually am kind of against that, to be honest, because I think it makes it more confiscatable than it is now. And so that's a hard thing to answer because, I mean, honestly, if you think about it truly in terms of market cap, if you were to measure what Bitcoin has the potential to be for one Bitcoin, I mean, right now you're under $1 trillion market cap. It could reach potentially like $36 million per one Bitcoin, right? If you take all of the economics of real estate, investment, money markets, money supply, put that all on top of Bitcoin, then, I mean, one Bitcoin's worth plenty of money. Now, once we get there, I think investing will be a lot easier to do on top of Bitcoin. But yeah, currently with altcoins and stuff, I mean, personally, I don't believe in altcoins, mainly because of proof of stake. I don't think proof of stake can work in any regard or fashion. But if you want to invest in certain things, I definitely recommend that you research them in depth and why they are an altcoin, what they aim to achieve. Because certain ones, like Cardano, I guess you could say, I think something like that, they don't really have the goal to be like, well, to compete with Bitcoin at all, and to bring more smart contract functionality. But I look at them, if you were to compare it, I look at like Cardano or Ethereum or Solana, like companies, you know, like Twitter, Facebook, early days of the internet, right? I mean, Google was created in 1998, and you can think of something like that as an altcoin in a way. Now, some of the altcoins actually do try to aim to become money, like Ethereum, actually. Ethereum, in my opinion, is stupid. I will say that. And there's a lot of reasons why, and a lot of altcoins, I believe, actually every other altcoin, or every altcoin, I do not believe is decentralized. So Bitcoin is honestly the only true decentralized blockchain. And I mean, I can argue with people on that all day. So, yeah.
Yeah, I agree with that.
Other questions? Yeah.
Did you say 2041 was when the last block that you mined, or what was that?
2,140.
I was completely backwards. That was like,
No, you're good.
what would theoretically happen then?
Yeah.
to
So
everything?
I do have an answer for that. So the blockchain will continue to work. Like, it's actually pretty funny. If you look at the math and how the bit shifting works, 21 million actually will never happen, which is kind of weird. But also there will be no block rewards still, because you get down to past one Satoshi and the miners won't receive like any reward. So what will happen, you have to think about this, like what incentivizes the miners at that point, right? Because currently right now they're getting 6.25 Bitcoin. Now, understand, to be a miner on the network, it's really not that profitable unless Bitcoin goes up, because it costs pretty much the same amount of money getting 6.25 Bitcoin as it does to put the amount of electricity cost in. So if you're looking at stuff like that profit-wise, it's really not the greatest profit unless Bitcoin does go up, which I think it will. But in terms of what happens after 2140, I think transaction fees will be a great incentive for miners. They already get transaction fees, like I just showed you, was 12 cents, right, per transaction or something. Now the miner of that block, according to how many transactions are in a block, usually, I mean, I see up to like 2,000 transactions per block. The miner will get all of that, but we are going to shift into a world that I believe that layer one transactions would be a lot less common. And it makes sense because at that point, well, one, like I said, the Lightning Network, I mean, if you're reaching 1 million transactions per second, I mean, there's really no reason to make transactions on layer one unless they need to be on layer one. And transactions like that would be like, in today's terms, like $1 trillion transactions or $1 billion transactions, which to a miner, they'll earn plenty of money to mine that block, or just have any of those transaction fees. That's what I think is going to happen at that point. I can't say for sure because, well, one, I'm not going to be alive. I don't think. But I mean, this has been an issue to talk about since the beginning of Bitcoin. I mean, even the environment issues and stuff on Bitcoin with Bitcoin mining, how much electricity it consumes. I mean, that was something that was discussed a week after Bitcoin was released. So, I mean, honestly, in terms of the environment problem, I think that's more of an actual energy problem versus a Bitcoin problem. Because, I mean, I'm not going to get into the politics of it, but yeah, if that answers your question.
So what I heard from that was more, instead of the last block would be mined, it would be like the last payout of that, like 6.25
Correct.
Bitcoin would be paid for mining the block?
Correct. Yes.
Okay.
Yeah.
And it
At,
would
yeah. At
shift
that.
into that.
Yeah. At that point, I'm trying to remember what the fee would be. I mean, you're getting down to like it'd be like 0.000025 Bitcoin or something.
Yeah.
Yeah.
Okay.
Yeah. Which hopefully one day is a lot of money. But, yeah. Any other questions?
When you were saying like a difficulty adjustment based on how much processing power on the network,
Yep.
what is adjusting that difficulty?
The code. I mean, yeah. I mean, put in the plain terms. So there is a function within Bitcoin's code that it looks at because that difficulty, the hashing power of the network, it does adjust. And at all times, the code looks at that. And I'll show you real quick. So you can see remaining difficulty adjustment. From the last one that just happened today, I think, you can see that it's actually down 0.9% from the last adjustment. And the reason for that actually is because of Kazakhstan, sorry. And because 12% of the hashing power fell, it came back up. But depending at that 2-week time, which is actually a certain amount of blocks, the reason we can say it's 2 weeks is because it's roughly comes out to be 2 weeks. At that time, Bitcoin will look at what that hash rate is in its code because that variable adjusts. And then the nodes on the network will agree that the difficulty should be this, just within its code. So really hard to explain, like exactly how it works because it's just in C++ and what it is, but yeah. Hopefully that answers your question. Other questions? And this cannot be over Bitcoin either. It can be over other crypto too. So. All right. Sweet. Well, that's it for the presentation today. I mean, if y'all are interested in possibly stuff to go more in depth into, say, Lightning Network or anything like that, I don't know if Jake and Mike or Mario, anyone, y'all just want to maybe have me again for anything, but yeah. I mean, I really, really appreciate your time and being able to listen to this because for me, as confused as I was over what Bitcoin actually was, I mean, I want to actually teach people what it is because I think it is honestly one of the best technologies of all time. So, yeah.